You wake up alone. No phone, no map, no compass, no roads, no signs. Just an endless forest stretching in every direction.
Every tree looks the same. Every path disappears into 100 identical paths. At first, you stay calm. You'll recognize something eventually. But after 2 hours, nothing changes. The sun vanishes behind thick clouds and panic creeps in. You don't know which way you came from. You don't know where your family is. You don't even know if you're walking towards safety or deeper into danger. If this happened 50,000 years ago, your odds of survival would be terrifyingly small. Not because of wolves or starvation. Those came later. The real killer was getting lost. Every wrong turn carried you farther from water, shelter, and the people who knew where to find you. And yet your ancestors did something that sounds almost impossible today. They crossed entire continents with no GPS, no compass, no written directions, and somehow always knew where they were going. Experienced hunters could leave camp before sunrise, chase an animal for dozens of miles through unfamiliar terrain, and return to the exact same campsite after dark without a single wrong turn.
Movies love to show confused cave people stumbling around hoping for the best. Archaeology tells a completely different story. Ancient humans weren't wandering. They were navigating with astonishing precision because the world itself was their map. Every hill, every river bend, every bird call became part of a mental navigation system modern humans have almost entirely forgotten.
Here's the strange part. They weren't born with a magical sense of direction. They simply learned to notice things you and I ignore every day. So what happened to that ability? Did we lose it, or is it still hiding inside us? It starts with the thing rising above your head right now, the sun.
The sun was humanity's first GPS. Every morning it rises in roughly the same place, crosses the sky, and sets on the opposite side. Today we barely notice. We wake up indoors, drive in cars, and let our phones tell us where to go. For your ancestors, the sun was information. After watching it rise thousands of times, they didn't have to think that's east. Their brains just knew it.
This trained instinct still shows up today. Many Aboriginal Australian languages barely use words like left and right. Instead, people think in absolute directions. Move the cup slightly southwest, not move it left. Researchers found that children in these communities can point to true north accurately, even inside unfamiliar buildings. Most modern adults fail that same test instantly. Not because we're less intelligent. Our brains were simply trained on a different system.
But the sun has limits. Clouds hide it. Forests block the horizon. So when night fell, an entirely new map appeared overhead. The stars. Cultures memorized exactly where constellations rose and set, which ones moved with the seasons, and used them to travel enormous distances in total darkness.
No one mastered this better than the Polynesians, who crossed the largest ocean on Earth in wooden canoes. No compass, no engines, nothing but memory. They read star positions, the direction of ocean swells, seabird flight paths, and cloud formations stacked above distant islands. To everyone else, the Pacific looked like empty water. To them, it was covered in signs.
But what about dense forests, where the sky disappears completely? Even then, ancient humans navigated, because the real map was never above them. It was all around them. Every unusual tree, every oddly shaped rock, every riverbend became part of a three-dimensional model stored inside their minds. Neuroscientists call this a cognitive map. You're not just following a route, you understand the entire place.
We've actually measured this. London taxi drivers spend years memorizing more than 25,000 streets before earning a license, and brain scans show their hippocampus, the brain's spatial memory region, physically grows larger from the practice. Now picture a hunter who spent not 3 years, but 30, walking the same valleys and rivers every single day. Their mental map would have been almost unimaginably detailed.
And because landscapes constantly change, rivers flood, trees fall, storms reshape forests, your ancestors needed something even more reliable than landmarks. They needed to read the living world.
To us, a forest is background noise. To your ancestors, it was a conversation. A skilled hunter could walk in and know within minutes if something had changed. Birds were nature's alarm system. A sudden silence in the canopy could mean a predator just moved through. And indigenous trackers across Africa and Australia still read that silence today, long before a human eye would catch anything. Even insects gave directions. Bees travel between their hive and water, follow a line of them across a dry landscape, and there's a real chance they lead you to a stream. Dragonflies rarely strayed far from ponds. Tiny creatures were quietly revealing the map to anyone patient enough to notice.
Then there was tracking itself, reading a single footprint like a sentence. Fresh or old, calm or running, carrying young. Researchers studying sand trackers in the Kalahari watched hunters follow a single antelope across miles of mixed terrain, even when the footprints vanished on rock, because by then they weren't tracking footprints anymore. They were reading bent grass, a flipped pebble, scratches on bark. This is also why your ancestors remembered the world as stories, not directions. Walk to the lightning split tree, turn where the rocks look like sleeping animals, follow the stream until the water turns loud. Aboriginal Australians took this furthest of all with song lines, entire songs that encoded hundreds of miles of desert geography, sung correctly to guide travelers across a continent. Long before paper maps existed, humans had turned memory itself into navigation technology.
So, were ancient humans just better observers, or did they have something closer to an actual internal compass? Modern neuroscience says a little of both. Your brain contains specialized neurons called place cells and grid cells. Place cells fire when you're in a specific location, like tiny markers switching on. Grid cells build an invisible coordinate system that estimates distance and direction even without visible landmarks. Together, they form what scientists call the brain's internal GPS. And like a muscle, it gets stronger with use. Which raises an uncomfortable question. If we all have this system, why do we get lost after one wrong turn? The answer is in your pocket. In studies comparing people who explored new areas using GPS versus people who relied on landmarks and their own sense of direction, the landmark group built dramatically richer, more accurate mental maps. The GPS group reached the destination just as fast, but their brains did almost none of the work. Psychologists call this cognitive offloading. When technology solves a problem for us, the part of our brain that used to solve it quietly goes idle. For your ancestors, that idle setting wasn't an option. A wrong valley could cost a day. A missed water source could cost a life. Nature rewarded attention and punished distraction without mercy for hundreds of thousands of years. That pressure is exactly why humans became such extraordinary observers in the first place.
So what happened to that ability? Nothing disappeared, it just went quiet. First came maps, then compasses, then road signs, then satellites that tell us exactly where to turn. Every invention made life easier, and every one of them quietly replaced a skill our ancestors spent hundreds of thousands of years perfecting.
That's also why getting lost still feels so unsettling, even with a phone in your hand. Somewhere underneath the convenience, your brain still remembers what being lost actually used to mean, and that fear never fully went away. The next time you walk outside, try something your ancestors would consider completely ordinary. Leave the phone in your pocket for 5 minutes. Notice where the sun actually is. Listen for the birds going quiet. Look at which way the shadows fall.